All right, let's get started. A very warm welcome to this October edition of Ask the Expert. It is a beautiful fall afternoon here in Stockholm, and we have some really cool demos lined up for you guys today. With me, I have Avassa's expert, Fredrik Jansson, solution architect, and an expert joining us from our partner OnLogic, Ross Hamilton, system architect. And today we will cover a very brief background to the close relationship between hardware and software that is very typical for a normal edge computing stack. We will learn more about OnLogic and their industrial PCs, and we'll also look at some very cool demos, all the way from actually unboxing the device itself to rolling out application at a larger scale. And with that, I'll hand over to Fredrik.
Thank you. Okay, so some background. We're using industrial IoT here as an example, but this could actually go for any type of vertical. The reason you go to the edge is you have a couple of applications that you want to run at the edge, and hopefully, or we hope that you choose Avassa, of course, to do your application management. But as you cannot run software out of thin air, you always need a server and you need an operating system to run the applications on. And OnLogic is a very popular choice among our customers, especially in the industry because of their rugged computers, but also in retail. And OnLogic is, of course, a valued partner of us. So we thought it would be a good thing to put together a demo, because we do get the question from our customers on, so once I have the hardware, how do I roll this out at scale? Meaning, how do I get an operating system on there? How do I get Avassa on there? So I'm very pleased to present Ross, and I'm actually going to hand it over to him to get the demo started.
Thank you, Fredrik. I appreciate it. Let me switch over, and I'm going to steal the slide share for now. Give me a thumbs up if you guys can see that. All right. So we're gonna briefly kind of talk about OnLogic, some of the computers we make, and then we'll really get into the demonstration, going through the unboxing, and then thinking about how we orchestrate that at scale. Amy and Fredrik, thank you so much for involving OnLogic in this demonstration. I think it's really valuable to be able to help showcase how we actually do this scaling at the edge, because you've got all these end nodes, these end devices that are sitting in a variety of disparate locations. And how do we actually take and deploy the software in a meaningful, reliable way is critically important. So thank you. A couple quick highlights, right? In terms of what type of devices OnLogic supports, we kind of have these four main pillars. We've got our industrial computers, which are really meant for those kind of more hardened environments that you might find on, for example, a manufacturing floor. They have some additional industrialization to them that you don't otherwise find in a typical PC that's like off the shelf. We scale that up, and we've got our rugged computers that really kind of go to that next level. They bring in a lot better support from a wider temperature range. We have wider power input options, and we support a lot of additional regulatory compliance with those and shock and vibration ratings. We support panel PCs that can be used for human-machine interfaces or be attached to any kind of devices that need that on-screen touch capability or kind of real-time analytics that you're looking for at the edge. And we support some of the edge servers where you want to take and perform a lot of the aggregation of that information from maybe a lot of sensors that are sitting out at the edge, where you want to connect that up, prune the data, and make sense of it before you make some type of decisions against it. Now, OnLogic, we kind of play in a variety of different areas, everything from energy, logistics, manufacturing, medical, to, as Fredrik alluded to, some of the retail, smart agriculture, smart city, and transportation. So when we think about the edge, we think about it in terms of all these different places. What do they require? What do they need? So our hardware is truly defined to kind of fit within these different segments. As far as the company goes, we are headquartered in Burlington, Vermont. We have additional US resources in Cary, North Carolina. That's where I'm sitting today. We have offices in the Netherlands and additional offices in Germany, as well as supporting offices and staff in Malaysia and Taiwan. Okay, so now to kind of the meat and potatoes of why we're here today, right? So we're going to go through an unboxing of one of our systems. We're going to do basic connectivity. We're going to power on the device. We're going to walk through some of the preparation that it took to actually get the system up online, installing the operating system, and then how do we then take that bare metal operating system and connect it up to Avassa Control Tower with the Edge Enforcer software stack. Lastly, we're going to look at, and Amy kind of alluded to this, how we're going to do that at scale when there's n number of devices that are out there at the edge, and you have to do this for all of them, because then it can be quite cumbersome if you have people running around with USB sticks in a manufacturing floor. That's just an untenable situation. Okay, so let's go ahead and get to the actual unboxing part of this demonstration. Behind me here, I have a box of one of our Carbon 430 platforms. So we'll go ahead and just take this out. And as you can see, hold this up to the camera, right? This is an OnLogic Carbon 430 platform. You pull out some of the additional accessories. So we've got an AC to DC power adapter that we're going to be using for this demonstration. Now, for anybody that might be unfamiliar, a lot of these edge devices have power requirements that it's necessary to connect in direct DC power. That's very useful if you're in some type of industrial control cabinet where that is readily available. In this circumstance, we're just going to be using a typical AC to DC power adapter where we can take and connect via terminal block to the power adapter that's actually on the system. So we'll get a direct 12 volts that comes right out of here through this green plug and goes right into the system itself. We've got some additional antennas that we can connect to the unit if we want to use or leverage Wi-Fi. Those would just go right here on these connectors and you would screw them in. I will go ahead and do that, but for this demonstration, I'm actually not going to be using the Wi-Fi. We're going to be connecting up through a hard line in our RJ45 port that you find on the opposite side of the unit here. Now, both of these ports have PoE capability, which is pretty cool if you had to connect any type of downstream sensor device.
Ross, can I ask, do all the carbons come with Wi-Fi?
Wi-Fi is an optional accessory that you can get on it. So it's an M.2 that we would install at time of manufacturing based on the customer's request. And that M.2 has internal connectors that come out and go to the face mount here so that then you can be able to directly access Wi-Fi from that. And just connect antennas and you're good to go.
Cool.
Yep. Okay, so my next step here is really to just plug this together. So give me a brief moment. I'm going to first start by connecting the power to the unit. I'm then going to connect a display port, Ethernet, and I've got a keyboard and mouse that I'm going to be using here to kind of help showcase and move this demonstration along. And you can see here from what is being shared on the screen, power went into the DC power connector. I used port 1 of my Ethernet connection. I used the DP connector for my display port. And then I use the USB 2 connections for my keyboard and mouse. Now, for additional information, if you want to learn more about this particular product, feel free to scan the QR code. It'll take you to the product page. It'll have additional information. And, you know, Fredrik, to the question you asked there, you'll be able to see we have some of the explicit options that can be selected during the configuration process.
Cool.
Yep.
Cool.
Okay. Now, the next thing that I want to kind of talk through is what we did in terms of preparation for this particular unit. Now, OnLogic also has a partnership with Red Hat, and we have Red Hat certified devices. I think Avassa, you guys also are a partner with Red Hat, right?
Correct.
So it seemed like a logical choice that we would leverage Red Hat for this demonstration. And it was really easy to kind of get done in terms of getting it set up and configured. Now, one of the things that I wanted to try and do is showcase how this could easily be done at scale. So I created a Kickstart file using Red Hat's Kickstart generator, which you can find by, again, scanning the QR code that you see here on the page. And you have to have customer portal access to be able to go ahead and create this Kickstart generator. But if you've got an existing Red Hat subscription, you'll be good to go. Now, a couple key highlights that I created for this Kickstart. I set it up for basic. It's relatively rudimentary, right? I wanted to just configure my time zone. I wanted to make sure that my root password was set to a value that I knew what that was going to be. I wanted to make sure also that I would clear out any existing partitions that may be on the device. If it was a new device, this probably is a don't care, but I've used this device in a few scenarios, and I wanted to go back through and just kind of make sure everything was cleaned up. I wanted to set up our network so that it would DHCP and enable a few firewall ports so that I would have access to SSH to the device. And lastly, I wanted to connect it back up to my subscription manager. So I was able to do, as some of the post-installation options during the Kickstart file, set it up so that it could tie right back and automatically register with my subscription that I've got with Red Hat. Now, this system itself is...
Once you have that file, what do you do with it? How do you get the device to consume that, so to say?
Yeah, so there's a process that you can follow. It really depends on how you're going to go through the OS installation. For this example, what I did is I created a USB device, and I was able to take this Kickstart file, and you can inject it into the USB installation, and you just put the USB device in there, and automatically, bada bing, bada boom, once the unit came up, you'd see the grub loader. As part of this process, I added a line item to the grub loader that was able to point to the Kickstart installation. And when it does that, it automatically knows, hey, go ahead and leverage this Kickstart file when the Red Hat installation is going on. And then it just automatically takes all those parameters and streamlines the whole installation process. So technically, I don't have to press a key. It just works and goes through, does the installation. When the system powers back on, I can just boom, 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 connect right in with my root credentials that I've already kind of pre-configured as part of what you see here in this encrypted password. It's a, actual password that isn't this long. And I'm able to just log in, right? So it's really easy. There's a lot of other options that can exist there if you wanted to do network installs. Red Hat has a lot of really excellent documentation that can walk you through step-by-step on that process. Okay.
Nice. Thanks.
Yep. And lastly, as far as the actual what gets installed perspective, I just went very plain vanilla with this. I said, I'm just going to use Red Hat server with the GUI. And I'll go ahead and play this video that you see here on the side to kind of showcase what this Kickstart installation process looks like. And Fredrik, while this is going on, one of the questions that I really had was what type of prerequisites or recommendations does Avassa have in terms of how to do the OS install or what packages are needed?
Yeah, so of course you need a Linux, and we do require, if you want all the features that we can provide when it comes to disk quota and stuff like that, with a 5.2 kernel or later. And that's really all we require. To run the actual installation script itself, you do need curl on the box.
Right.
But once you have that and download the installation script, we take care of installing the other dependencies that we have, like Podman or Docker, the container runtime. We use a tool called JQ to modify some settings on the box, but that's pretty much it.
Okay. So it's relatively rudimentary, and curl is generally installed with most based installations anyway, right?
Yeah, I mean, it just hasn't. It must be a relatively like 2015 or later version of the kernel. So
Hopefully we're there now for most
yeah.
Okay. Okay. All right. So I think now is time to actually start going in and exploring some of the live demonstration. What do you say?
Cool.
All
Looking
right.
forward to it.
Let me go ahead and figure out how to stop sharing here. And I'm going to try and flip over here, and hopefully, if all goes as planned, we will see me in the upper corner, and I should have a login prompt here. Okay, so I've just booted this unit up for the first time. For all intents and purposes, this is right after the post installation that I did with my Kickstart. So I'm going to go through, and I'm just going to log in with my root credentials. And I need to go ahead and figure out, how do I connect up to Avassa, right? What process do I need to go do here? So let me just bring up a terminal. Oops. And we'll just open up terminal. Okay, and I've got a little script that I created here that just will theoretically run the Edge Enforcer. Now, I just did a quick cat on that to kind of display and show the actual command that's going to be run. Fredrik, does this look right?
It does. It looks perfect. It
All
looks
right.
perfect. And I can just add that you don't have to know this command by heart. If you go into the control tower, the control tower can actually tell you this command. You can copy and paste it.
Exactly what you need to know. And for our instance, this is what we're using, right?
Yeah.
Okay. Okay, cool.
Perfect.
So I'm going to go ahead and I'm just going to quickly run and execute this script. And let's see what happens here. So it looks like I'm downloading and installing a couple packages, but that was pretty quick.
That was pretty quick. Yeah, I mean, we tried to make it easy on the distros that we support. So this is well, this should be everything you need to do on that box.
And I'm done.
You're good. You're good.
I now can connect up to the control tower stack and start managing this from the web UI.
Correct. And maybe let's switch over to the control tower and see
Yeah, good.
what's happening there.
And while you're doing that, I think I'll call out too that one of the ways that we could easily make sure to just run that command against any of the units is we could leverage the Ansible platform and use Ansible to just run a quick playbook that just runs that one-liner or runs the script. Maybe there's some other set of parameters that you might want as well. And you could just do that at scale across multiple nodes.
Cool. So you could use Kickstart to kind of install the operating system, and then something like Ansible to actually automate the finishing touch, so to say.
Yeah.
Really cool. Really cool.
Okay.
Yeah, so I actually see something here, an unclaimed host, local host, local domain with a host ID. So what actually happens now, since we haven't registered this particular machine in the control tower, it shows up as what we call an unclaimed host, meaning someone has installed our software, but no one has yet configured it.
Okay.
So let's add a new site here.
I think that looks like the box that I just turned on and installed the software with.
Yeah, and that's actually a good point. In the simplest case, we use the host ID as a shared secret or a unique identifier. There
Okay.
is also a possibility to, in the control tower, to require you as the installer to put a client certificate on there if you want to add extra security to make sure that the devices that call home are the devices that you want to call home to us.
That's good to know.
So I'll create this OnLogic Edge site. I just call it that, and then I click Add to Site down here and click Submit. So this is going to take a couple of seconds because the machine, since it wasn't allowed to register itself, it's going to back off a bit, but in a couple of seconds or half a minute or so, it will actually come here.
Okay.
And so what's happening is that the software is now in the background on your machine, trying to connect to the control tower, and the control tower would reject it until I created this.
Oh,
That
okay.
is what we're waiting for. And
So
once it
is
is,
my machine
yeah,
kind of sitting there saying, you know, hey, I'm available, hey, I'm available, and it's just doing that continuously. And eventually, once it does that again, the control tower is going to say, I got you, and I'm going to put you here.
exactly like that. So once it connects now, it will receive information from the control tower. Hey, your site name, as we call it, should be OnLogic Edge. If you have
Okay.
multiple machines that you want to form a cluster, all of those machines will receive a notification, say, hey, each of you have two friends, try to figure out how to connect to each other. All of that is handled automatically in the background.
Cool. Now it looks like
So
something just happened.
yeah, here it is. So if we click on it and I scroll down here a bit, we can actually see the Edge Enforcer, the agent that you install, actually reports some information. So we can see that this is indeed a box from OnLogic that we're running on. We can get some more information that we read from DMI.
Okay. Yep.
Red Hat 8.10, I think that was what you installed.
Absolutely.
With a certain kernel, 16 gigs of RAM, that's not bad.
Yeah. It's a little powerhouse.
Yeah, absolutely. Absolutely. And momentarily there will be we'll see some metrics around memory consumption and CPU and disks and all that.
Okay.
But I guess to finish this off while we wait for that, I have a couple of applications here, and one is our standard demo visitor counter. So I'm gonna go here to deployment. I'm gonna hit redeploy. Gonna click here and coming back up. Well, we could see it right there. We're
Okay.
actually not pushing this application. So in a couple of minutes, or not even minutes, a couple of seconds, I hope to say, we will actually see this container, this application up and running on your machine.
So you just in the last 30 seconds were able to say, here, I've got an application container right now, and it's already been pushed down to this machine that I've got locally here sitting right in front of me.
Correct. Correct.
That's pretty slick.
So I think that is pretty much it around this. I mean, you showed a really streamlined way of onboarding, getting the operating system, installing our stuff. I took over,
Yeah,
registered it. We got an application up and running. That's not bad for like 20 minutes.
that's pretty good. Now, let me ask you a follow-up here.
Sure.
We got a common customer and they're going to have 100 units, right? They're going to fill out an entire manufacturing facility. How do they look at this and scale that out? How does that work? We did one, but how do we do it for 100?
Great question. So, I mean, they would, of course, use Kickstarter in that case to get the operating system on, assuming that they choose, for example, Ansible to do the one-liner to install our stuff. Then we have APIs on our side, so you can automate this and actually get devices onboarded onto the system. So I
Okay.
actually checked that off here. And as you can see, I went from having like 4 or 5 sites to 100 plus. So what I did was I kicked off the last piece of automation, and through our APIs, I onboard these new sites. They start coming up in the exact same way as we did with the single machine, and you can see here they're starting to turn green one by one, a little bit depending on the timing when they call home and so forth, and the control tower accepts them. So I think with what you showed around automating the hardware, if I may say so, operating system and all that, together with some scripting towards our APIs, it's fairly simple to help this particular customer up and running.
Yeah. So you know, this customer having sites worldwide, multiple manufacturing facilities, you can see them just coming online, you know, on the map, and they're turning green relative to the status and kind of whether they've done the call home procedure.
Exactly like that. So call home, getting the configuration they need, basically getting the software up and running. And I can actually do the same thing then, even though they're not, all of them are up and running yet. I can go back to my deployment here, do a redeploy on my visitor counter, and all of a sudden I'm deploying the same application, the demo application, not only to your site, but I'm actually rolling it out across these 100 sites, or at least those are up and running when I got to this stage.
How do you group those sites together, right? How did you just quickly say, yeah, I want everything, you know, these applications to get deployed against all of those sites in tandem?
Good question. So what we typically tell our customers to do is add different types of labels to the sites. So for example, I'm going to choose, see if I can find one here that has some good sites. Oops, if I can do the right one, Stockholm cluster. So you can add your own types of labels to each site. So these could be like a region label or a type of customer label or blue, green, red, something that makes sense to you that you will use to control where your application goes. And then in your deployment, now I've done a bit of cheating here. I'm actually telling the system to roll this out to all my edge sites, except a couple of ones that are offline or finicky in other ways where I didn't want to run this. But basically, we use label matching to tell our system, put this application where.
Yeah, so if you want to put it everywhere, you can actually kind of use some basic logic there and say, and not these systems. That's
Correct.
Cool.
Correct.
Well, cool. I think that really kind of helps, you know, pull it together full circle, right? As to how we took a system and just went from an unboxing to a basic setup to how we can roll it out across the world.
Yeah, that blew my mind. That was really cool.
So quick question from one of the attendees here. Fredrik, you mentioned a shared secret between the OnLogic device and the control tower for a secure onboarding process. So what other security measures are at play in this platform?
Yeah, so that host ID, as we call it, is something that we try to read typically from DMI. So in this case, it was a serial, the board serial. Then, as I mentioned to Ross, you can add the requirement to use client certificates to uniquely identify each machine. Then once the system starts calling home, we store encryption keys and so forth in a TPM if there is one available. I would say those are, and then of course we use certificates, mutual TLS to authenticate each other and so forth. But those are the basic things, I would say, or base things.
Very cool. Thank you. So if you have any other questions for Ross or Fredrik, make sure to post them in the chat or send them directly to me. And was there anything else you wanted to show, Fredrik, in the web UI here, or should we switch back to our slide deck?
Let's switch back to the slide deck.
Awesome. So I know we are on the half hour here, but if you have any more questions, we'll stick around for just a minute or so, and feel free to post any questions for Ross or Fredrik in the chat. So question for Ross. The OnLogic hardware, is there any limitations in terms of temperature or other, if you have very rugged circumstances, what are, the question was specifically around temperature, but what limitations are there in terms of the surrounding environment?
It's highly dependent upon the platform. So if I kind of roll back, and as I was talking earlier around the fact that we've got these four main pillars of products, we've got our industrial line, we've got our rugged line, and then we've got panel and edge server. Kind of each one of those pillars has somewhat unique characteristics in terms of the temperature range that it can be supported at. For the most part, the industrial platforms are 0 to 50 C in terms of what they can support from an ambient temperature environment. Our rugged platforms really explode that out and can go all the way from -40 up to 85 in certain circumstances. So there's a huge temperature range that they can be supported at. And one of our mutual, one of our mutual customers is leveraging this exact same platform, the Carbon 400 series, in an environment up in some of the mines of northern Sweden, where it gets down to those -40 temperature ranges. So it's pretty cool to see that actually out in action.
Wow.
Very cool. And as a Swede, I can confirm that it becomes very chilly. Very cool. Thank you, Ross. Also, regarding OnLogic, does OnLogic also support SUSE Linux?
We don't formally support SUSE Linux. If there is a specific inquiry around will it be compatible, and there is a strong desire to look at that, it's definitely something that we can assist with and provide some guidance relative to the support pathway there. What I will say is that relative to the support structures that we enable with both Red Hat and Canonical in terms of our general Linux support, generally speaking, we should be quite covered across the board between those two suppliers. There's always caveats.
Got it. Thanks.
Mm-hmm.
Question for Fredrik mainly, I guess, and feel free to jump in, Ross, as well. So how does this compare to Red Hat Device Edge software?
Oh, great question. So first and foremost, we have done a lot of testing with RHEL for Device Edge. If you're not familiar with it, it allows you to compose an image with Red Hat Enterprise Linux on it that is with an immutable file system with an A/B partitioning, which adds the extra secure safety, I would say, that if for some reason when you do an upgrade, the system can automatically detect that this wasn't great and automatically roll back, do a reboot, come back on the old partition. And we have made sure that Avassa works great in that environment. And also, I didn't talk about that, integrated our operating system update feature together with Red Hat, so you can actually control or allow Avassa to control the upgrades for RHEL for Device Edge. I hope that answers the question.
So it's complementary, you would say?
Yes, absolutely. Yeah. Absolutely.
Awesome. Thank you. So I am mindful of time, and thank you for keep posting questions. We will finish up this session, and I'll make sure to post contact details for both Ross and Fredrik to a follow-up email to all of you who has attended afterwards. So if you have any more questions, I'm sure they will be happy to answer. Thank you so much, Ross and Fredrik, for your insights and for sharing that really cool demo.
Yeah, thank you. Appreciate it.
So we'll be back in November 20th to be precise. And yeah, thank you so much for joining us today, and look forward to seeing you next